So now we know vertex form. Vertex form is easy to find the maximum or minimum of the quadratic. We have the factor form. The factor form has the brackets. You can identify the equation by what it looks like in its form. This one has the brackets, so it's good for finding it at the zeros. Today we're going to be studying about the standard form. Standard form is in the form ax squared plus bx plus c. So if you just see an x squared without any brackets, note there is no brackets, we know it's in standard form. Okay? Now, when we have these, we should be able to graph or sketch. You should be able to sketch anything there. Note, what is the standard form good for? Well, standard form is good for C. The last term without an x variable is the y-intercept. Okay, so each form has a different characteristic that it's useful for. For example, the first equation is good for finding the vertex. Factor form is good for finding zeros. Standard form is good for finding the y-intercept. Okay, it's good for the y-intercept. So if we have to sketch, we can actually use this to find out the vertex as well. We can actually find the vertex in this form. The vertex, the x location of the vertex is going to be equal to negative b 2 times a, where b is the middle term, a is the first term here. Okay, and it's the same as the standard form. After all, I know you can just add up your two zeros and divide by 2. That's the line of symmetry. So you can find the line of symmetry, and then you would have to substitute that in to find out your y location. After we have that, and we know the y-intercept, and also the step pattern, we know that quadratics are symmetrical, then we can graph it. So let's have a try. Let's do an example. Sketch y is equal to 2x squared. Let me get an equation for us here. Oh, yes. 2x squared minus 12x plus 15. So the first thing that we're going to do is we're going to find out the vertex. Let me just move that so we can see. Okay. So it's 2x squared minus 12x plus c. Well, so let's first identify our variables. What is a equal to? What is b equal to, and what is c equal to? Nick, what is the a term here? What is a equal to?
A is equal to 2x.
And we just take the term or the leading coefficient. So a is equal to 2. B is equal to minus 12, and C is equal to 15. Okay? So if I need to find the vertex, if I want to find out the vertex, we know that the vertex is going to be equal to, write the equation down, negative b 2 times a. Okay? So therefore, x is going to be equal to negative b. So it's going to be negative 12, okay, 2 times a, which is 2. So we're going to have 12 divided by 4, we get 3. Now, we can start with our sketch. We can start with our sketch here. Anytime you do a graph, make sure you label your x and y axis. That's the very first thing that you do. Now we cannot put the zeros because we don't know the zeros, because this doesn't give us the zeros unless we use the quadratic equation. So let's draw the vertex. The vertex is at 3. 1, 2, 3. Make sure you have a scale. Draw the line of symmetry. That's the line of symmetry, okay? That's where the vertex will be on that line somewhere. We need to find out where the vertex is, so we're going to substitute this into our equation and find this out Bruce, can you find out what is the y output? Y will be equal to, and then we put in this x value, so it's going to be 2 times 3 squared minus 12 times 3 plus 15. Can you put this in? What do I get? What is the height of the vertex? What do we get? Bruce, what do we get?
-3.
We get -3. So therefore, the vertex location is at 3, -3. Plot that on our graph here. We have 3, then we go -3. That's the vertex. That's a point. Okay? Now, after I know the point, the second point that you're going to use is the y-intercept, because we know this form is the y-intercept. That means when x is equal to 0, this will be 0, this is 0. It will be guaranteed to be the last number. Guaranteed. So we go up here, 15. Label 15. So I know that that it's going to go here. And we know that these are symmetrical. So I know that it's going to go here, and there's 3 units here. So if I go over 3, boop, 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 it's going to go through this point here as well. Okay? And I could just graph it. There we go. That's how to graph using the standard form. Okay? We find the vertex using this equation. Okay? Then we find, we put that in, we find out the vertex. The vertex was 3, -3. We label our axis there like that. We can also find more parts because we know the step pattern. The normal step pattern of a quadratic is when I go over 1, I go up 1. So the normal step pattern is 1, 3, 5. Okay, that's the normal step pattern. And if I have a value of a, that means that we're stretching, then you just multiply those by the value a. So you would multiply by a, a. So in this case, we could also do the step pattern. In this case, a is equal to 2. So my steps will be 2, 6, 10. 2, 6, 10 are my steps. So if I wanted to find some more points just to verify that my graph's working, it means that if I go over, let me change the color here. If I go over 1 unit, so if I go, for example, over here 1 unit, I would go up 2. 1, 2. Oh my goodness, look, that's the point right on the graph. And then if I would go over 1 more, I would go up 1, 2, 3, 4, 5, 6. Oh my goodness, I got a point right there. And if I went over 1, I would go up 10. I would be at this point right there. Okay? So minimum, we need to have 3 points for graphing. I would use the y-intercept. Use the vertex. And if you know that it's symmetrical, so you can go over the same amount of units. If you're not too sure, then you can find more points using step over 1, up 3. Over 1, up 2. Over 1, up 6. Depending on what this value is at the very beginning. The normal steps is 1, 3, 5. In this case, we're going to go 2, 6, 10. And that's how you can graph using the standard form.